In this problem, we want to determine the number of possible integral divisors of this number, 49,500. So in order to do this, what we need first is the prime factorization. So in order to do that, first we need to, let's see, we've got two zeros here, so we can peel that off. So we got 100 times 495. Now 100 is 10 squared. Now I know I can divide 495 by 5. So let's see, 49, yes, that's 9. So 45, so we get 45, so 99. All right. Now 10 squared, that's 5 times 2 squared. 99 is 9 times 11. And then we've got 5 squared times 2 squared times 5. 9 is 3 squared times 11. So let's put some factors together because these are together. So we got 2 squared times 3 squared times 5 to the third times 11. Okay. So now, how do we figure out how many different divisors there are? Well, let's pick a simpler number. Let's pick 6. How many different integral divisors are there for that? Well, we have 1, 2, 3, and 6. Now, the way 6 breaks down is we have 2 to the first times 3 to the first. Now, with 1, we get that by taking 2 to the 0 times 3 to the 0. Let's get this a little closer, shall we? There, that's a bit better. We have 2 to the 0, 3 to the 0. With 2, we have 2 to the first times 3 to the 0. With 3, 2 to the 0 times 3 to the first. And 6, it's 2 to the first times 3 to the first. So basically what we say is, well, 2 could either have a power of 0 or 1. 3 could have a power of 0 or 1. So there's 2 options here, 2 options here, so 2 times 2 is 4. So we take that same logic over here. Let's put a 1 here on 11. Now over here, 2 could have a power of 0, 1, or 2. So that means just right here, there are 3 possible factors, just using the 2. But now we do the same thing with the 3. It could be to the power of 0, 1, or 2. So times 3 for that. With 5, it could be 0, 1, 2, or 3. So that means times 4. And with 11, it could be 0 or 1. So that means times 2. So now we multiply these. So we get 9 here, and we get 8 here. And then when we multiply these, we get 72. So that's how many integral divisors there are, because we take the prime factorization and list out all the different possible power combinations from 0 on up to what we have.